And our next speaker I'd like to introduce is Dr. Manjir Samanta Laughton.
Hi, thank you for having me here, and it's good to see you all. So, shall I just go straight into it? Yeah. Okay, so what have black holes and the cosmos got to do with Earth energies? And this talk will really go nicely with the whole day, and especially what Philip was talking about with chakras to do with the Earth. So we're going to see what this is all about. So Philip took us way out to above the Earth and looking at the planet from a different perspective, and we're going to go even further now. We're going to go out into the galaxies, into the cosmos, and we're going to reference it all back to our inner space and the Earth itself and Earth energies. And I'll come here with, questions for you guys, because you are experts in Earth energies, you're experts in dowsing, and I would like to know from you if you think that the theories that I'm talking about today make sense for you from what you find in the practical applications that you're out there looking at dowsing, looking at ley lines, and if what I'm saying today is making sense for you. So I'll come here with a bit of a favour to ask as well, so if that's okay. So you're the peer review today. Okay, so yeah, that's me. And so what I'm going to speak about is there a connection between all of these things? Is there a unity theory? In physics we look for a unity theory that can bring the very, very large, like the galaxies, the atoms. Is there anything that can bring chakras and consciousness and even our weather and Earth energies together? And people have been looking for a unity theory for many, many years. People like Einstein, we've got string theory, we've had Faraday, and so we're always looking for new ways of bringing things together. And you're probably all aware that we're moving from one scientific era into another. And is everybody okay with hearing me? Do you want to need the mic, or are you okay? Yeah, okay, brilliant. So we did have something called the clockwork universe, the Newtonian paradigm, and in that Newtonian paradigm, what people thought was that if you break everything down, if you understand all of the parts, then you understand everything there is to know about something. And hence we have, I come from a medical background, I'm a medical doctor by training, so hence we have the situation that you go to the hospital and they go, right, okay, your lungs go over there, your heart goes over there, and they don't see you as a whole person because they see you as the sum of the parts and no more. But obviously the holistic movement is seeing you as more than the sum of the parts, and that if you bring something together, there's something emergent, there's something more than just your mechanics, just your mechanics altogether. So this is a situation until the beginning of the 20th century that we thought everything was mechanical parts, and we started to look deeper into the atom, and that's when we got our first shock that the atom really is a lot of sort of empty space, and we don't really know what that space consists of even to this day. And so that was a big shock, that we thought, well, we're firing things at it and we're actually finding very, very little. But it ended up with that picture of the electrons going around a nucleus, and the protons, the neutrons, the electrons. And people thought, okay, that's all right. Well, they used to think of atoms as solid sort of billiard balls, the smallest particle that you can come into. I mean, it actually comes from the Greek word for indivisible. But then they thought, well, okay, we've looked into the atom and seen there's a lot of empty space, and we found these subatomic particles. Maybe these are indivisible, and that's what people expected. And that was the situation until again we got to the 1920s, 1930s, and we ended up with the era of quantum physics. Has anybody heard of that here? Yeah? Okay, brilliant. Right, you're all... Has anybody seen things like What the Bleep and things like that? Yeah, okay, you're all up with me, right, brilliant. I'll just go very, very briefly into this. So as we all know in this room, because it's so gemmed up, we entered this weird world of quantum physics where when before we thought that the world was happening as a machine and we had no input into it, suddenly with quantum physics we found that reality, that particles change their behaviour according to the way that we measured it. I won't go into the details of the experiment, but that was the bottom line. So you suddenly had this thing called wave-particle duality, whereas the particles change their behaviour according to how we measured it. And so some people started to think, well, what does that actually mean? That reality, that particles actually change their behaviour according to how we measure them. And so they were going, well, what is measurement? So this was around the 1960s. You've got the era of experimentation with drugs. You know, there's a lot of physicists who are also hippies, you know, and they started to think, oops, what does that actually mean? So they started to think, okay, when you observe something, when you measure it, you're observing it, and what does it take to make an observation? It takes something with consciousness. Even if you measure it, you don't look at it, and then you come to it later, you still see those quantum effects happening, and you still need an agent of consciousness for that, you know, that wave-particle duality, well, you know, where things exist as a wave of possibility until you actually measure, and then it sort of decides what it wants to do. But until then, a particle exists as a kind of possibility spread out, almost in infinite possibilities. So it's only when you measure that it actually comes into actuality. So people started to think, okay, it's an agent of consciousness, it's something observing that makes that possibility wave actually turn into what we would call an actual something, you know, an actual sort of point particle. So people started to say, okay, there must be something to do with consciousness that actually interacts with our reality. And that was the big sort of revolution that started to happen, you know, from the 1930s, that, you know, we realised that we participate in our reality. From the 1960s onwards, a few physicists, not all of them, have started to realise there must be something related with consciousness related to reality. And amazingly, just in the last month or so, Max Tegmark, who you might have seen on BBC documentaries and Horizon, he seems to be a favourite, he's actually announced that consciousness indeed has something to do with reality. So he's a mainstream physicist. But really, people like the people in What the Bleep, like Fred Alan Wolf, have been saying and been speaking, and this is where I want to really have our basis for what we're going to talk about in this hour. So people like Amit Goswami, Peter Russell, Elizabeth Rosher, they were really pioneering physicists who said, you know what this means? This means that consciousness is fundamental to reality. It's not that consciousness is produced by the brain, you know, because the brain itself is made up of matter. So how can that, which came first, the brain or consciousness? Because how can the brain, if it produces consciousness, collapse down, you know, reality of itself, because it's actually made up of atoms itself. So they ended up resolving this by saying consciousness is fundamental to reality. So is everybody following me so far? Mm-hmm. Yeah, okay. So this is the basis from where we're going into black holes and how this all links together. So, you know, matter now, we're starting to get this idea, and as I said, Max Tegmark, and this is big news because, you know, mainstream physicists have been poo-pooing this for a long time. And, you know, when someone in the mainstream takes something up, you often see changes starting to happen. Everyone goes, oh yeah, I knew that all along. You know, even though before they were sort of poo-pooing it. Does anyone know how long it took before anyone took notice of Einstein? Does anyone know? No, it took 4 years after he published. Nobody took any notice of him at all. And it was only 4 years later when, you know, the actual Max Planck had actually published something, and he happened to be the head of the editor of a very prestigious journal, that people started to take notice of him. And can you imagine that? It wasn't the work itself, it was that someone important said something about his work, and then it gave permission for everyone else to comment on the science and to take notice of it. So often it works like this in science. When somebody important and somebody prominent says something, then it gives permission for everyone else to agree with it. That's how it works, with human beings. So this is the basis of what we're going to be talking about. So going to be really going through the black hole principle in a nutshell and why it's relevant for Earth energies as well. So what it is, why it unifies the forces, and we're going to go beyond the speed of light, give a bit of the evidence for it, make the predictions of why it's linked to water as well. And that the water aspect is another thing that I'm coming here with you with a question, how does this fit in with your experience, of ley lines of dowsing. So, just to recap, we're told the story of the universe is a Big Bang, and it had this great explosion. What exploded we still don't know, and then from there everything spread out and you get the planets and the cosmos. I don't think you can see it very well on there, it's a bit dark. And then 15 billion years later, we end up with something called the Standard Model of Cosmology. And this is currently how scientists think that the universe is. This is what they think it consists of. And, back in the early noughties when this model was sort of really elucidated and clarified, they got out the champagne because they thought, finally, we can call ourselves scientists. We've got evidence at last. Because the cosmologists previous to that actually thought that they weren't proper scientists. Because the cosmologists actually look at the universe as a whole. So what the universe does, how it evolves. And, science is about, can you repeat the experiment? Well, you can't repeat an experiment with the universe as a whole. So they didn't feel as if they were proper scientists. And then they started to send these telescopes out and get this data, and they thought, brilliant, we're proper scientists now, we know what the universe is about, we've got our own standard model. And before that, I don't know if you know, but there was have you heard of the Higgs boson, the so-called God particle? Okay, that's part of the standard model of particle physics. And we'd had that for a few years already. And so the particle physicists had their standard model, but the cosmologists didn't. And so proudly they said, yes, we've got our standard model, we know what the universe consists of. So what did they come out with? Well, most of the universe is something called dark energy. Now, they absolutely have no idea what this is. Absolutely no idea. And then, but they know of its effects because, we can see that the universe, if it started in a Big Bang, and I'm not saying it is, but this is what they think. So if it started in a Big Bang and the universe started expanding, then what we should see is that after a while, all the stuff in the universe exerts a gravitational pull on everything else. Does that make sense? And so after a while, the universe, instead of expanding and speeding up, should be expanding but slowing down as it expands. Does that make sense? And in 1998, shock horror, we realised that the universe is actually accelerating away. And this was not expected, and this was from measurements. And so they went, well, there must be something pushing it apart. And they went back to Einstein's equations and went, oh, how clever, Einstein put a lambda constant in his equations. He knew all along, even though he thought it was, he called it his biggest blunder. And so people went back to, even when he thinks his wrong is right, so people started to do that. So this is what they call the dark energy, the force that's pushing the universe apart, and we have no idea what it is. And then the 23% is dark matter. Now we know that exists because when the galaxies are sort of, spinning around that we see, and all of the stars and everything in them, they should be flying apart. But they don't, because they've calculated there's not enough physical stuff to hold it all together. So they've gone, oh, what could be, there's not enough gravity pulling it all together. So they're going, well, something's exerting a gravitational pull on all this stuff in the galaxies. What could it be? We don't know, but we can see its effects because it's holding the galaxies together. So they call that stuff dark matter. So again, that makes up a huge chunk of the universe. And then the next bit is 3.6% intergalactic gas, and these numbers slightly change depending on what chart you're looking at. And then everything physical, including yourself, what we would call physical, is this 0.4% stars, etc. And that etc. includes you, me, that chair, this hall, every single planet, everything. So, but nevertheless, they got the champagne out and said, we know everything there is to know about the universe. So this, I kid you not, is a standard model. And there were actually people saying, it's over, cosmology's over, we've done it, we've sorted it, there's nothing more to discover. Which is quite amazing. But, but then people started to think, okay, we're sending out these telescopes, and these telescopes are coming back with information that doesn't fit this model. It doesn't fit our theories, it doesn't fit what we're expecting to see. And a lot of the time, has anybody watched something like Morgan Freeman's shows and things like that, and what's that guy called, Brian Cox and things like that. A lot of the time, when they don't know something, they act as if they do. And, it's, so they go, I was once in sitting in a GP surgery with the person who was mentoring me, and someone came in with something on his toe. This man came in with something on his toe, and she said, well, it could do this, it could do that, and just make sure that if it doesn't go away, you come back to see me in a few weeks. So, and then the guy went out, the patient went out, and she turned to look at me, she goes, I have absolutely no idea what that is. But she wasn't going to tell the patient that, because then he would lose faith in who she was. And she goes, it doesn't matter, because I've told him if it gets worse to come back. So in the same way, the scientists and people with authority don't like to say that they don't know what's going on. So whenever they find something unexpected, they go, oh yeah, that fits in with our theories, because if you middle that with there and you have this, and we knew that all along, but a lot of the stuff they're bringing back is unexpected. But some of the scientists, the sort of young Turks, not so young anymore, are actually saying, maybe we have got it all wrong. And they actually produced a BBC Horizon documentary, which is called something like, maybe everything we knew about the universe is wrong. And after this programme, people were calling me up going, that stuff you talk about, you're right, It's like, thanks for believing me, but there are all these scientists that came on this show and actually said, maybe we've got to throw away everything that we know, because what we're getting from our telescopes doesn't fit our theories, doesn't fit our models. So that's Pedro Ferreira at Oxford University. So these are mainstream physicists who are saying, maybe we've got it wrong. And there are just things that just do not fit. And one of those is really, really relevant to what we're going to talk about with the faster than the speed of light. And it's called the horizon problem. And if the universe really started... Is everyone all right or too much science?
Well, it's good.
Yeah, okay. Not in total overwhelm and shock. And one of those things is called the horizon problem. I don't know if anybody's heard of that. No? Okay. So can you imagine if the universe started with a Big Bang, and you got everything sort of spreading out, and so it started, Big Bang. We don't know what banged, and so we still don't know, but they just kind of carry on regardless. And so I've actually seen Neil Turok of Cambridge give a talk where. Just to, fill in for the fact we don't know what started it all, he put a little hand, the hand of God started it all. And this is a physicist at Cambridge. You know, so you have this, something bangs, and from a very, very tiny spot, it spreads out, and it spreads out very rapidly, and inflation, but with Alan Guth's inflation theory sort of says that there's this period of rapid expansion. Now, when it gets, can you imagine if this is the speed limit, this is the limitation of the actual universe spreading out, yeah? So in the first few seconds, say the universe gets to about there, then a few, infinitesimally small moments after the actual universe is created, you get light being created. Because obviously, if nothing existed before the Big Bang, light was created afterwards. Yeah. So I'm not saying the Big Bang is true. So that, but this is what this is one of the problems that you have with Big Bang theory. And so what happens is, the light then spreads out, and you get a horizon. Yeah. Okay. So that's horizon of light. So it's spreading out just moments after the universe itself is created. So you've got the universe horizon there, and you've got the light horizon here, yeah? Do you understand that? So now, there should be, 15 billion years goes by, and there should be a difference from those parts that were in the universe without the light, and those parts in the universe in the light. We should be able to see those differences 15 billion years later. Yeah, but we don't. We don't. What we see is that the universe, no matter where you look, even if you look sort of many light years away from us, looks the same no matter where you go. Everything just looks the same. In a way, it's kind of like a fractal, but we'll get on to that. And so that's the problem. That's known as the horizon problem. And, just while we're on that, if you think about it, if the Big Bang is true, then what you're seeing, what you should be seeing as you go deeper into the edges of the universe that we possibly can look into, is you should be seeing the universe getting younger and younger, because light has taken time to travel to us. Yeah, does that make sense? Yeah, that's not what we see. We see old stars, new stars. Even if we're going so many light years away, we still see older galaxies, formed galaxies. We should be just seeing baby galaxies, baby stars, that sort of thing. But we don't. We see it, and that's another problem with the Big Bang. So it's not as if there aren't problems with this story. And although Morgan Freeman and Brian Cox may give you the off-pat view, they're not telling you the full truth. And the young Turks will tell you it's like that GP who told the patient, blah, 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 this is going to happen, that's going to happen, come back and see me. They don't want to tell the public that they don't know what's going on, so they keep with the story, even though the evidence is not backing up the story. Yeah? So that's what's going on in science at the moment. There's another problem, which is known as a flatness problem, which is we don't know exactly why the universe just happened to get the exact right proportions so that it doesn't close in on itself and it doesn't blow apart. It's got exactly the amount of stuff in it so that it just is, what is known as sort of flat. So it's not too much, and it's got, why did it get that exact, critical density so that it did that? Why did it happen to do that? And physicists don't like things that are perfect because it implies some intelligence behind it, something. So that's another problem. And so in order to solve these issues, a chap in University of London Imperial College called Joan McGagerow, I think I'm pronouncing his name right, now this isn't relevant to us because it's going to be relevant to our black hole theory. Okay, but he actually tried to save the Big Bang issues. Right, so he wasn't looking for a new theory, he was actually trying to solve the old one. So he saw the problems in the old one, do you remember the horizon problem? And he thought to himself, well, what would happen if you just broke one of the rules in physics. And that rule is nothing can go faster than the speed of light. So Einstein came out with that rule, and we've been enshrined in it ever since. So he thought to himself, what if in the early universe light actually went faster than it does now? So this theory is called varying speed of light theory, or VSL for short. And so when he came out with it, there was a lot of shouting at him as being a heretic, da da da. But anyway, this is a genuine physicist. He's a professor. He's, at the time he was only about 32. So he's now a bit more established, I think. But he was, in a University of London, tenured as it were, physicist. So he didn't just leave it there though. This is a genuine physicist. He's doing the calculations, and he actually said, this would make more sense. The universe would make more sense if light was actually infinite. This is from his calculations. He said it would make more sense if light was infinite. And what happens is it gets curled up in higher dimensions. Yeah, and so he revived something called the Kaluza-Klein theory, which Einstein actually rejected. But what Kaluza and Klein, two different physicists, actually said was that there was a fifth dimension to the universe, and that idea was actually taken up by the string theorists in the 1980s and 1990s, when they created their string theory, saying there are many dimensions to the universe, and of 11, 26 dimensions. They were building on the Kaluza-Klein theory. For some reason, Joao doesn't like the string theory. He calls it something quite rude, which I won't say. If you want to know, you'll have to read his book. But so he said, he revived that theory, and he said that he thinks that light is actually curled up in higher dimensions. And what we see as the speed of light is just this bit. Does that make sense? But actually it's going a lot faster because it's in higher dimensions. And this is a genuine physics theory, So and so that really was the inspiration for me to realise that, I think we've got it all wrong. That there isn't really a speed of light as such. Is everyone following this, or is that you're looking a bit puzzled? Is that you okay?
Me?
Everyone, you're all looking a bit puzzled.
Rupert Sheldrake, in some of his books, has pointed out how the speed of light is actually variable.
Yeah, I met him on. I was just with him on Wednesday, in fact. So yeah, we talked about that, in fact. But he talks a bit more about the measurement of the speed of light and how it's referenced by itself. So this is sort of before Rupert Sheldrake started to talk about all this. This is a varying speed of light theory that came out in around 2000, and when Channel 4 made a documentary about it. And the hits on the website about the show were actually the second highest, second only to Big Brother that year. So the interest is like huge. I know. Do you remember Nasty Nick? It was second only to that moment. So the interest is actually massive. So we have the. Sorry, somebody else wants to say something. Is everybody happy or at this stage?
Not just comment on your wavelength about the high dimension.
The wavelength to the high dimensions. Sorry. In this, I'm not going to talk about it so much at the moment, but just because wavelength almost is implying there's a space and time. There's different ways of talking about string theory. Sometimes you talk about it on a background of space and time, and some people don't. High dimensions. So for this presentation, what I'm going to say is that there are different levels of the universe, of different dimensions. So let's take string theory and Kaluza-Klein theory, and go on to as saying that there are different dimensions to the universe. And from the start, we talked about consciousness, didn't we? So what I say is there are different dimensions of consciousness. So because we said consciousness is fundamental to everything. So what we're going to go on to is, okay, if there are different dimensions of consciousness to the universe, then where are they? Okay, and where do they come from, and how does it all work? And then we'll tie it all in with your own inner world and earth energies. So if we can do all that in, how long have we got now? Okay, we've got like half an hour, yeah? Okay. What I started to realise is that, looking at all that, I suddenly had an insight, which was the speed of light is not the speed limit of the universe at all. You've got this mainstream physicist at Imperial saying that speed of light it makes more sense if it's infinite. It just gets expressed in different dimensions. So I realised that what it is not a speed. It's not a something moving along. So if you think about it, photons are actually moving at the speed of light. So Einstein said nothing with mass can move faster than the speed of light. But photons and some other sorts of particles actually don't have mass. Yeah. So how are they moving at the speed of light? So what I realised is that because the speed of light is very, very strange in that. See, if I was to see Philip on the street and he was walking along, and so I come along and say, "Oh, hi Philip, I met you at Leyhunters," this kind of thing, and I would have to accelerate to walk beside him, yeah. And so then we would, hopefully you wouldn't say, oh, not you, that. And so we'd end up walking side by side. So relative to each other, we'd be going at 0 speed. Does that make sense? Mm-hmm. Okay, so the speed of light isn't like that at all. If you were to try and catch up with a photon, even if you're going at 29999 kilometres per second, and you're really, really going fast, you get to approaching infinite density at that, infinite mass at that point. But what would happen is that you would still see the speed of light going at 300,000 kilometres per second. So I realised that it's not a speed. What it is a reflection of a vibration of consciousness. And so the speed of light is because everything is consciousness. Remember at the start we said that? Our physics is starting to say that. So if everything is consciousness, what you've got is the speed of light is like reflecting the limitation of the vibration of the 3D world. So everything below what we call the speed of light is a world of what we call mass. And it's true that nothing from this mass world, the 3D world, can go beyond. But I realise that there probably are many, many different worlds that we can't perceive because they're not in our normal consciousness. So what do we call the people who... So I've renamed the speed of light as a perception horizon. And so that's C. C is the symbol for the speed of light. Okay, so... But beyond that perception horizon, what we normally call the speed of light, those are the dimensions that we're talking about, and those, I feel, are the mystical realms. So, because what can go faster than the speed of light? Your consciousness. Your consciousness does not have mass. We just did a meditation where we went to a different space and time effectively. We went from this normal space and time, and some people went somewhere they weren't expecting because they left the ego wheel behind and they were going to a different zone altogether. So the mystics have always moved their consciousness into different realms, and some people can even go to very, very vivid realms, like they say they've been on alien spaceships and all sorts of things. So they leave their consciousness. Now, very few people can actually move their physical being and materialise and dematerialise. Those are really, really strong adepts. But they're actually changing. They know how to, with their consciousness, change the vibration of their very matter and move it to a different frequency. And that's how they materialise and dematerialise. But you're still not taking your physical body to a different dimension. You have to actually change it in order to go. So I realised that there's so much more to the universe than we're told. And all of that dark matter and dark energy that we were told about before, well, what is it? It's all of that stuff beyond the perception horizon. And the reason why we can't measure it is because physicists at the moment only see the physical world. They think that that's all there is. So that's what they're measuring, that's what they're looking for, and they can see the effects of the other stuff, the dark matter and the dark energy. But because they are only looking at the physical, the stuff that they can touch, measure at the moment, everything like that, because their measurements, instruments are below the speed of light. So that's all they're going to pick up. But we all have within us a faster than the speed of light measurement instrument, in that we have our consciousness. And we now understand our brain is no longer the originator of consciousness. Consciousness is everywhere. And we just take the information from the consciousness that's everywhere through our brain. And that, includes channeling. I mean, this place is being founded on somebody who's been channeling. You can take that information through the brain. Okay, so what's all this got to do with black holes then? Well, and earth energies. Well, if everything that is dark and black is actually light, well then we can really, really reframe black holes and see that there's a different picture altogether. Now, people are probably familiar with this concept of black holes, yeah? And has anyone seen like Star Trek and that sort of thing? Yeah. So usually people find out, I mean, science fiction writers love it because you've got, this situation where they're going to be sucked in and, just at the last minute spaceships getting rescued and you're going past the event horizon and this and that. So the old picture of black holes is something that came out of Einstein's theories. And the idea was space and time curves so much that you end up with a place of infinite density and infinite gravity. And anything that goes past this event horizon is like the place of no return. And there's tons of writing about what exactly happens, what would happen to someone if they went past this event horizon, would they even notice? There's lots of speculation about what would happen. But the idea is that it sucks in everything that goes past, and even light, hence they're called black holes. And John Wheeler in the 1960s coined the term as a joke, and it ended up staying. So now we call them black holes. And they're thought to sort of lurk in the darkest recesses of the galaxies. But until quite recently, nobody really knew if they existed. Because we didn't have the telescopes, we weren't sort of doing the space exploration that we are doing now. So this idea that these black holes are just sucking everything that comes near to them is still sticking. People still think of this idea, even though the actual evidence is against that, really, as we'll see. So the big shock was that we started to find black holes absolutely everywhere in the era of telescopes. Okay, so this was the big shock. They weren't expecting to find black holes like at the centre of every single galaxy. That was the big shock. So they weren't just at the centre of the galaxies as supermassive black holes, they were all over the galaxies. And the strange thing, because they're supposed to actually be sucking everything in, black holes, they actually were doing something rather strange, because they give off lots and lots of material, usually in the form of these bipolar jets. Did you remember that from that diagram earlier? Yeah, so you've got these two jets that are coming out. So why is it that black holes, which should be sucking everything in, are actually giving off loads of material? Why are they so bright? So when we actually started to look at the evidence did not fit the theories. So instead of black holes being rare, the black holes were at the centre of every single galaxy and all over the galaxies. And instead of them being black, they're actually super bright. They're bright. So that's how we recognise them, because there's so much stuff coming out of them. So at this point, you'd have thought the scientists would go, maybe we've got it wrong. But they don't, because once you've invested so much down one path, you keep going, because it's kind of like a blind spot. So, sorry? Oh, I thought somebody said something. Okay, so what you do have is you've got electrons coming out of black holes at nearly light speed. You've got positrons, which are particles of antimatter, and they are the sort of the doubles of electrons, the mirror image of an electron. And you sometimes get gamma rays, which are formed when an electron and a positron actually join together. So why have we got all this stuff coming out of black holes when they should be actually sucking everything in? Well, this is when I had the big insight in 2003. I realised that this is actually the creation process. It was I was out in the woods. We were talking about the negative ions and the wood and the fact that I was out walking my dog in the woods, thinking about all these things, and I suddenly had a very, very strong vision. And I've been speaking about this ever since, and presenting at universities and things around the world. And so what I realised is that the black holes are not destructive. We've got it wrong. They're actually creative. And what happens is you've got this infinity, this singularity at the centre of light. It's actually a source of light. They're sources of light. And what happens is the light spirals around through the dimensions, and it gets to the edge of our reality, that perception horizon that I was talking about. And then the light splits into two, and it forms an electron, which is a particle of matter, and that goes into the speed of, below the speed of light region. That's what we call all of our world. And a positron, which goes into the antimatter region. And don't worry too much about this, but it goes into the c² region, the antimatter c². So it splits into two and forms our world and a kind of mirror world. Okay, is everyone making it? That makes sense? So that's what I kind of saw in a nutshell. Sorry, are you gonna?
One thing, could you just clarify again what causes the perception horizon?
What causes it? It's just the different levels of light going at different sort of consciousness, as it were. So it's kind of like a vibration of consciousness. So we happen to be seeing things from this perspective. But we're actually multidimensional beings, so we've got different aspects of ourselves as well. So we've got aspects of ourselves that are in different regions that can see. But at the moment, we're aware of being in this hall, being with these people, and that's our main awareness. But we have other awarenesses as well. So it's just where consciousness happens to find itself. So there's kind of like a limit, almost like a quantum leap, like the atom is a quantum leap, where there's a level that it's kind of like, well, it's a bit complicated, but it's like light references this one level, and as light references it splits and it becomes like a particle of matter, but that particle of matter is always referencing the speed of light. And that's kind of what the equations are about. But anyway, it's quite a complex question now, exactly what. Okay, so do you want to go through that again? So the light from the centre of the black hole, it spirals through the dimensions, and sometimes it's easier to see the line drawing sometimes. So, and then it reaches the edge of our reality, that perception horizon that I was talking about, which is also called the veil. In esoteric, it's called the veil. So that's at the speed of light. And then the photon splits into two, so you get the matter and the antimatter happening at that level. And we see electrons streaming out. Why are they just below the speed of light? Because they've only just slowed down. That's why. And they don't understand why these electrons are moving so fast. But the reason why they're moving so fast is they've only just slowed down to our realm. And we see them coming out of nowhere with our telescopes, when we know, in this room now, that they're actually coming from a higher dimensional process. The black hole is actually producing them. Does that make sense? Yeah, okay, so they've only just slowed down. And you see all sorts of fluffy kind of excuses in science because they don't understand what's going on. So there we go, those are these bipolar jets. So the higher dimensional geometry of the black hole, the end point produces these bipolar jets. Okay, so and that's a long story, but we can see the actual jets. In actuality, this is a picture of a galaxy. So this is a Hubble Space Telescope. So this is sort of evidence. You see this double helix coming out. So the spiral is a very, very important signature of the black hole principle. You also get, remember I said the positron and electron turn back into a photon? It's a breathing process. It doesn't just go one way, it goes the other way as well. The two combine and they produce photons in the terms of a gamma ray burst. It's like the dance, the flow of the Tao or the dance of Shiva. These are all referring to this continuous breathing of the universe. There's no set point. So what happens when we get this breathing is we get the gamma ray bursts that we've been seeing in the sky since for over 50 years. And this breathing is going on at every single level and at every single black hole, so we see these patterns just, oscillating. Now these patterns, you can see these are genuine, this is genuine data. They're actually a complete puzzle to the scientists because they think in terms of physical, do you remember? They think in terms of physical things bashing about because that's all they know. So what they don't understand is this gentle breathing process. So when they see gamma ray bursts, they think something's collided into each other or something's exploded. Right, but that would produce a different pattern in the data. An explosion would be very, very bright to start off with and then die away, yeah? That's not what we see in the data, and they don't understand it. And right now, there's probably a number of people running around the world to inform each other there's a gamma ray burst happening. And they turn into these massive cosmic stamp collectors because they go and they measure it and they look at it, but then they have no idea how to make sense because what they keep seeing is objects in the sky suddenly become very, very bright. It can take seconds, it can take minutes, or it can take even days or sometimes even weeks. And then it dies away again. And they don't understand why these patterns are happening. They don't fit an explosive pattern. So everyone happy with that? Yeah? So it's this breathing process as the positron and electron come together again, they form the gamma ray burst. Yeah? Okay, so you're happy with that, yeah? Yeah, you're looking at quite puzzled some people. Okay, and then the other thing that happens is these X-ray fluctuations. So the electrons that come afterwards, do you remember I said the electrons, sometimes you have the electrons that come out of the 20. So sometimes the black hole breathes one way and produces the electrons and the positrons, and sometimes they combine and breathe the other way and produce a photon. It's also known as a zero-point field, if anybody said, this is what causes a zero-point field. But we'll go into that in a sec. So you have this, but they don't understand that. So you have these X-ray fluctuations which are caused by these electrons. So you not only have the gamma ray burst, you also have the X-rays. And to them, do you remember they're thinking in terms of explosions? To them, they don't understand. Why is it that suddenly you have a gamma ray burst and then you have an X-ray explosion? So they've come up with a theory that black holes are having postnatal burps and hiccups. Because they don't understand it. And these are scientists. And as I said, they don't understand it, so they think the black hole is a baby guzzling on food, and just like you tap a baby on the back and get it to burp, suddenly these X-rays are coming out, and but you can see the source of the flares is unclear. As I said, they do not understand what is going on. So if you look at Brian Cox and we know, it's like that GP saying to the patient, come back, it'll do this, it'll do that. She didn't know what was going on really. So, and that's nothing against her, but at least she admitted it, So, to the public, they don't admit that they don't know. So they say, do black holes play with their food? Now, can anyone tell me what this is? Yeah? Do you know which galaxy? Yeah, it's our own. This is home. So this is the Milky Way, and to their utmost surprise, they found these, guess what? 2 jets of gamma ray bursts. First of all, they found these bubbles. Do you remember the headline, 2010 is a galaxy brain bubble? Okay, these are the 2 gamma ray bubbles that were not apparent in the first pictures. They had to do some resolution of this. So can you see, and then they resolved it even further, and they found that there were these 2 jets, these 2 bipolar jets of gamma ray bursts, exactly what we would think. And can anyone see what's happening here? Yeah, can you see that what's happening is these jets are spiraling? Yeah? And as they're spiraling, they're producing these bubbles. Can you see that? Yeah. So I think even a child could see that, but what they're saying is that these are ghosts of a previous explosion. Because they just can't understand this is a current happening. Our own galaxy is giving out gamma rays, just in the same black hole principle that's happening at every level. So it is something that is happening at every level. It's not just the pattern out in the universe. What I'm saying in this theory is it's happening at every single level. I'll give you some evidence of this and why it's relevant to your chakras, to the earth chakras, the earth energies. So if I'm right, we'll see these concentrated bipolar jets, we'll see evidence of the phi ratio, geometry. The emissions are going to be fluctuating and unpredictable. Emissions are often greater power than expected, faster than the speed of light. There's several different types depending on what level of the universe you're talking about. You sometimes see new creation. There's a light, matter, antimatter, all of these things. And you see these fractal patterns. And plus I'm going to be talking about the water. So this again looks like a bipolar jet of a galaxy. But it's not. It's actually a star. So the same pattern of the bipolar jet we're actually seeing around stars. And we're seeing them around young stars, old stars. And they're puzzled by this because they don't understand how young stars and old stars can have so much energy behind them. This should be a familiar sight. This is our own star. So what do we know the sun to do? Give periodic flares. And coronal mass ejections, periodic flares, and what's in them? Guess what? X-rays, matter, antimatter, everything that we'd expect. So what I'm saying is, and I'll give more evidence later, is the sun is also, like any stars, is the same black hole principle on black hole principle, black holes and black holes. And the sunspots are like the sun's chakras, as it were. They are the larger black holes, and it goes all the way down. And you see most of the flares coming out. You see the flares coming out of the sunspots. Yeah, so the sunspots are also there. And my book was published in 2000. I first published in 2003. The book was published in 2006. What do we see now in 2013? Solar flares fire off antimatter particles, exactly as we'd expect from my theory. And this is mysterious, though, that they weren't expecting it. But if you understand this theory, you can start to expect it, you can start to make predictions. We also see very, interesting fluctuations coming off planets. Jupiter even lost a stripe for a while. Do you remember that? When Jupiter lost a stripe, got it back again. But people don't understand why Jupiter is also giving off flares. Sorry, did you want to ask a question?
To comment on Jupiter.
Can we leave it? Is it okay to leave the comments go? Just aware that we've got just 10 minutes left.
It's to do with the Maxwell equations.
I think we're going to that's a big subject. We're probably going to leave it till later.
No,
okay.
it's just,
and then we're probably okay. And also you get comets. Now people thought that comets were having the comets were just these snowballs out in space, but they didn't realise that comets also give off jets. So even something that we think is quite simple, and something you are also quite familiar with, do you know that the moon has eruptions as well? Yeah? And people kind of didn't understand this because they thought that the amateur astronomers who were reporting these eruptions were completely deluded, making it up. And then someone decided to collate all of these reports from amateur astronomers, and they realised they were correlated. So the moon itself is giving off eruptions. So what does this mean? Is the Earth itself a black hole, if everything's showing this pattern all the way down? Okay, what do you think? He's starting to... Okay, surprisingly, we've got quite a lot of evidence for this. I mean, we can see the sort of spiral patterns happening in the weather. One of the biggest ways that we can see the evidence is in thunderstorms and with lightning. Now, lightning, when it hits the ground, is about a third the speed of light. And we're told that lightning is produced when there's too much static electricity in clouds. What we're not told is nobody's ever proved that. And we're not told that the measurements do not prove that there's not enough static electricity that actually builds up to produce that amount of power. It just isn't there. So again, another example of the public being told something because they're too embarrassed to say that they don't know. So what we do see though, now we have the era of satellites and we can see above the clouds, two different types of lightning like sprites and things like that, is we can see gamma ray bursts happening in the Earth's upper atmosphere. And they're the same type of power that you see in black holes out in space. Yeah, and you know, I always say this should be headline news, you know. So you're seeing the same gamma ray bursts, and they named them after the fairy realm. You know, so you've got elves and sprites and things like that. And what you're seeing is this radial expansion at the speed of light. And then what do we think? What do we know the lightning to be? The electrons that are coming out of the black hole. Okay, and what would we expect? We've got the gamma ray bursts, we've got the electrons, what's the other part? The positrons, the antimatter. This is a finding, I think it was actually 2011. The beams of antimatter were found. Now that was predictable from this theory. As I said, it was published years before this. But completely unexpected from the point of view of NASA. They were not expecting it. They weren't expecting terrestrial gamma ray flashes. So there's ironically, we know in detail how black holes work at the centre of distant galaxies, but we don't understand what's going on in thunderclouds. They can't make the connection, you know, that they're actually the same process. So, you know, the other thing with the Earth, so looking deep into the Earth, we haven't got that many measurements of what's happening in the actual planet itself, what's at the centre of the Earth. But actually the first measurements that we've got are, guess what, antimatter. You know, so what I'm saying is that Earth itself is a black hole dynamo, and you've got those, just like I was talking about the sun, black holes on black holes on black holes, that we should rename them. They're not really black holes, but that's what we call them at the moment. You know, so we're seeing the same black hole process happening at every single level on the Earth itself. And we're starting to see the evidence from terrestrial gamma ray flashes all the way down. So when we talk about this from David Hatcher Childress, you probably recognise it. When we talk about the Earth chakras, when we talk about sacred places, what we're talking about is different black hole spots on the planet. There are larger ones, there are smaller ones, and it goes all the way down. And so we've got this kind of pattern. Is it all right if we just go over by about 5 minutes? Is that okay? Yeah? Okay. And so this is a volcano. You probably recognise the process. What do we see in there? Lightning. Yeah? Can you see that? Yeah? And spiral plumes as well. Those plumes are not just random. They're spirals. So volcanic eruptions again are this black hole principle going all the way down. And you know, we see this all the way down into atoms. You know, we can now see that what do radioactive atoms produce? Gamma rays, beta particles, you know, which are electrons. The same pattern is going all the way down. We have electrons and positrons, again, spiraling around each other in an atom. And they give off photons. We use these on neon lights. You know, so we're seeing the same pattern. If you know how to look at things in a new way with this pattern in mind, you can see it all fitting together. And just to say that, you know, it's not completely, this is a quite scary picture in New Scientist. You know, it's not out of mainstream that black holes can happen at every single level, even inside us. So even mainstream science is actually saying that. We can redefine chakras. You know, they are, again, what, you know, interdimensional processes of spirals that bring through, you know, this, bring through the matter and create our bodies. You know, so we've got a new definition of chakras. so that the black hole's inside you. Again, DNA is known to wind and unwind, to breathe and give off light. So, is everyone convinced about that? Yeah, okay. So, what's all this got? How does all this relate to water? You know, how is it that black holes and the cosmos, what's it got to do with it? Well, you know, what's really, really, you know, interesting is that what actually happens in thunderstorms, apart from the electrons, the thunder, the lightning and the sound as well, I haven't gone into sound, the rain. Okay, so for my theory to make sense, you know, that the same process is going at every single level, is it possible that water comes out of black holes? Now, I had this idea when I was looking at the thunderstorms, thinking, well, that's a black hole and that produces rain, then maybe all black holes produce water. And I was just kind of like, nah, that's too crazy, that can't happen, da da da. And I didn't tell too many people about it, that I was actually working on it. But guess what? In 2011, they found huge, you know, black holes out in the cosmos, and it produces water. It actually produces water vapor. So this was one of the big, and they kind of publish it, and they don't actually say anything about it because it doesn't make sense to them. But it's not just there. Water has been found on many, many different places, from Jupiter's moons. They're called mazes because they are mixed with microwaves. So on Saturn's moons, even on our moon, you know, we're seeing water everywhere, even coming out of comets. This is comet Hartley, and it's got jets of H2O coming out. And this is probably the most unlikely place you'd expect to see water coming from the sun. So water jets actually coming from sunspots. So it's the same process happening in our upper atmosphere in thunderclouds and thunderstorms that's happening out in the galaxy and at every single level. And do you remember going back to volcanoes? During earthquakes, we see water coming out of the ground. I think James is going to talk a little bit more about, you know, places that have water coming out of the ground, what that means. And most of the gas that comes out of a volcano is not ash. You know, we're told it's an ash cloud, it's water vapor. So 60% of total emissions is water. So the same sort of level, every single level. And, oh dear, I'm going over, so what do you want me to do? Carry on, okay. Okay, so really interesting, people don't know how water got to the planet in the first place. You know, people think it might have been an asteroid or a comet hitting the planet, but we don't know for sure. So that is a big mystery. So what I'm saying is that the water is actually produced from the black hole dynamo at the centre of the planet. You know, if we're seeing the same pattern at every single level, even on the sun, water jets coming out of sunspots, completely unexpected, you know, then this is how the oceans are actually produced. And we also see, and I think what happens is when the polarities split, remember the matter and the antimatter, when that happens in a black hole, water is produced. That's what I think is happening. And you see that in our own emotions. When we're happy, when we cry, you know, there's all those things, we produce water. You know, at birth, and you know, even during orgasm, there's fluids being produced at extremes in ourselves. So I think when we have those extremes of any way, we see the water, we see fluid being produced. And of course, the waters of creation are often mentioned in many creation stories. You know, we talk about the primordial waters, the ancients talked about that. And we had some talk about Atlantis earlier. So I have a new theory for the flood. I'm not going to go into but you probably heard about the lost continent of Hiva, we've heard about Lemuria, but the Easter Islanders think that originally there was a lost continent of Hiva. So just to say, the flood stories are all around. And what I think happened was there was a change in the black hole dynamo of the planet, and it produced, suddenly there was a shift in consciousness, because at the heart of all this is consciousness. and the Earth itself went to a different level, just like the coronal mass ejections happened. And when that happened, it produced an awful lot of water from the central black hole of the planet. And when that happened, we got the flood that all the people of the world talk about. You know, it was produced from the central black hole of the planet. A huge amount of water came through the dimensions, a splitting of the polarities happened, we entered into further and further away from the golden age, and as that happened, it flooded the Earth. So the scientists don't know where the water came from the Earth, and this is a new theory of the flood. I'm just going to go over that, because so this is my new theory of the flood. So just to come back to the Big Bang, did it happen? Well, actually the data does not fit the Big Bang. We are in a universe of continuous creation, so I'm going to go where, and this is the sort of microwave data that fits that, but I won't go into that now. So we're in a universe of continuous creation at every single level. You know, so the same pattern is simple. Nature is simple. You don't need to have guzzling monsters. You don't need to have big explosions. You don't need galaxies eating each other. There's a simple, elegant pattern of nature that's breathing from higher dimensions, bringing in the light from different dimensions, and that's producing the matter, the antimatter, and then it breathes the other way and it produces a gamma ray burst. And that's why our rocks are radioactive. You know, because this is what's going on. This is what I think produced the flood and the water on the planet in the first place, and the water on the moons and all these unexpected places. I think Earth energies are the minor and major black holes of the planet. That are, you know, and you've got the central black hole dynamo that's producing the Van Allen belts. If I got that right, Van Allen belts. Yeah, that are fluctuating wildly. So Earth energies, the water, they're all produced from this black hole dynamo of the planet. It's the same dynamic that's happening all throughout the cosmos. So I don't know what you think of that. And it's all linked to consciousness as well. Okay, so